Ready? So I write for every epsilon greater than 0, there exists a delta greater than 0 such that 0 less than, remember, x minus 10. So x 10 go with delta, and the function plus minus minus 5 plus 5 with epsilon. Function limit with epsilon. So our first step, I have negative 4/5 x plus 8 in absolute value less than epsilon. Inside, I have the least common denominator. This is what I recommend. Other ways are fine. I'm not saying not to, but I recommend this. So then we have negative 4x and plus 40. Would you agree? Then I will factor at the top negative 4 and I get x minus 10. And now I write the absolute value of negative 4, the absolute value of x minus 10, the absolute value of 5 less than epsilon. This is 4, this is 5. I multiply both sides by 5 over 4. So the absolute value of x minus 10 less than 5/4 epsilon, which is our famous delta. How do I know to stop? Right here. That's all I needed on the left-hand side, and that's what I got. And that will always happen. And in step 2, show that delta equals 5/4 epsilon works by reversing the steps such and such. So this is a problem literally of, I don't know, 2 minutes, 3 minutes at the most. I don't want you to spend more than that amount of time on this. Okay. I still would like to look at a numerical example. Because you can say, okay, this is the theory, fine. Show me a numerical example where this is applied. So let's look at the numerical example. Any questions on this so far? Not difficult, right? Are we okay with this? Okay. So I would like to look at problem 3. I like the graph on this one. Okay. It says, did I start that? I did, I'm sure, yeah. So use the given graph of the square root of x to find a number delta such that, exactly what we know, x minus 4 less than delta, then the function minus the limit, the function minus the limit in absolute value, the distance between the square root of x and 2, less than 0.4. So what is given in the problem? Excellent. How much? 0.4. That's it. So epsilon is 0.4. The limit obviously is 2. Epsilon is 0.4. That's why this is 2.4. Epsilon is 0.4. That's why this is 1.6. So now we know that. Do I have my pencil? Because I want to erase this. Okay, I do have my pencil. So the question is, which one will be delta? Will delta be? I think that this appears to me to be longer. Will the delta be this? No. And the reason is I could pick x here and look what happens. F of x does not fall within 0.4 of the limit. So if I do not choose the smallest of the two intervals, I have the risk that I pick x here, and then the corresponding f of x will not be within epsilon away from 2, will be further away from 2 than epsilon, the length of epsilon. Okay. So then the other option is this, with the smallest, right? And now it's secure. Why is it a certain situation? Because if I pick x anywhere I want, f of x will fall within epsilon away from 2. But if I choose the larger of the two, there is a risk here outside. Okay, so what we need to do then, only one thing, which means we have to determine these two values and choose either this distance or this distance, but we already know which one we are going to choose. The smallest of the two, exactly. Good. So now we have to determine this and we have to determine this. What do we need to solve? Exactly how we started on all our problems. We start from the end. We start from the absolute value of the function minus the limit less than 0.4. In order to solve the inequality and determine this point. Decide which one it is. Okay, ready? So this is problem 3 on page 117. This is the applicability of what we're looking at. Okay. And then we can put this topic to rest. So we were given epsilon that you perfectly identified as being 0.4. And we have to determine the solutions and solve this inequality in order to find delta. Right? This is the f of x minus the limit less than epsilon. So now we have to dig deep about solving something like this. It's an inequality, but the question is what type?
Like square root. Is that rational? Or there's a word. I don't know.
Let me read it to you. The absolute value of a function minus 2 less than 0.4. What type of inequality is it?
Absolutely.
Thank you. Good. How do we solve an absolute value inequality?
This one.
Okay, let me refresh your memory on this. This is too important.
You take the value and put them on both sides.
Just dictate and I'll write it.
So it's negative 0.4 less than the absolute value, or not the absolute value, but just x minus 2, or square root of x minus 2 less than 0.4.
That's it. But I need to explain, since only one student remembered this, obviously we need to refresh our memory on it. So if I'm asked to solve something like this, with the equal symbol or without the equal symbol, it doesn't matter. Here is, I don't want you to memorize this. You just have to read it. Let's read it together. The absolute value of x is the distance between x and 0. The absolute value of the square root of x minus 2 is the distance between the square root of 2 and 2. The square root of x and 2. This means the distance between x and 0. So we are told to find numbers whose distance from 0 is 3 units or less. 3 units or less. 3 units or less. Where will I find those numbers? X between. That's it. That's how we translate such an inequality, an absolute value inequality. 3 units or less away from 0. But what happens if we have the opposite one? With the equal symbol or not, it doesn't matter, same idea. This time, just read the inequality. Don't memorize anything. We're asked to find numbers whose distance from 0 is 3 units or more. This one, 3 units or less. The second one, 3 units or more. How do I write the solution of the second one?
Negative infinity, negative 3.
Yes, or like this first, correct? And yes, the solution here will have the union. Yes, awesome. The solution here is just an interval. Yes, perfect. Thank you. So now we're going back to our inequality. That's the reason why Sabrina said, okay, this, you will convert it into this. You will change it into this because it's very similar to less than. So we're asked to find numbers whose distance from 0 is 0.4, is less than 0.4. So those numbers have to be found between negative 0.4 and 0.4. Well done. Now we have to come back and solve. How do I solve this inequality next? What do I do? It's a compound inequality now. Why? Two different inequalities. One, the other. But we solve them together because they are in a chain. These two, you cannot solve them together. They're not in a chain. One says to the left of negative 3, to the left of negative 3, and the other one says to the right of 3. But this says between negative 3 and 3. So what do I have to do to solve for x? First step. Okay, second step. Just kidding. You have to give me the first step. Yes?
I don't know how, but you gotta get rid of the 2. And then
What do you think?
adding.
Of course. The inverse operation, of course. 1.6 less than the square root of x less than 2.4. We're adding 2 to all three sides, absolutely. 2 on the left gives us 1.6, 2 in the middle gives us the square root of x, on the right hand side 2.4. Okay? We're solving for x. Yes, only because I would never say that to you, but in this case, I can. Why am I allowed to square? And normally, I'm not allowed to square all three sides of an inequality like that. I can't. But these are both positive numbers. The square root of x is a number between two positive numbers. So then I'm allowed to square. So when I square this, I get, what do I get? Some people are lazy tonight, which is me. I'm talking about me.
2.56.
Yes, less than x, less than, and 2.4 squared, 5.76. Okay. Now remember, don't forget, I have to have the absolute value on this side in order to identify delta. If I don't have the absolute value on this side, I can predict delta. So these are our options. We either choose the absolute value of x to be less than 5.76, which will give us between negative 5.76 and 5.76, or we choose the absolute value of x to be less than 2.56, which will give us between negative 2.56 and 2.56. Exactly. So choose delta, the smaller of 2.56 and 5.76. Minus 2, of course. We have to go back. We're not done. And minus 4. We have the 4 here. Sorry. So this is 4. If this is 4 and this is 2.56 and this is 5.76, we have to choose delta. So let me put those on the real line so you can see. So we had 4, we had 2.56, and we had 5.76, which means that this distance is 1.76, and this distance is 4 minus 2.56 is 1.44. Correct me if I'm wrong, please.
Yep.
Okay, so now we have to choose delta, the smallest of the two. Which one? 1.44. And now it's guaranteed that if we choose 1.44 for delta, it's guaranteed that every time you pick x, f of x will fall within 0.4 away from 2. So that was the idea. The numerical example. Any questions? Any questions? Okay. So there is no need to look at the absolute value like that. So this is basically what we determine. We determine those two numbers, and we have to choose the smallest. That's good enough. There is no need for more than that. Questions? Questions? Mari, go ahead.
I said not currently.
Okay. I'm sure you'll find something when you start working in WebAssign,
Oh, absolutely.
because there is no way we can finish everything in class. Okay, so I still have about 15 minutes, so let's start 2.5, continuity. I'm giving you a few examples. Is the first function continuous everywhere on its domain?
Yes.
Yes, because I graphed it without lifting the pencil off the paper. I know, my cheap marker. So this is continuous. What about this function? It has an infinite discontinuity. What about this function? It's continuous everywhere else on its domain, but it's not continuous at this point. It has an infinite discontinuity. What about this one? Very good. This is called the jump discontinuity. And there is one more type. This is called removable discontinuity. First of all, what does it mean? I'm going to put some numbers in here, or letters, it doesn't matter, A and L. So the removable discontinuity means that the limit as x approaches a from the left of the function, of course this is our function, equals the limit of the function as x approaches a from the right, but it does not equal the function value at that point. That is what we call removable discontinuity. The limits left and right exist, the limit from either side exists, because the limits from left and right exist, and the limit from either side exists, but those two values, or the value of the limit, they are the same. They are the same, but they do not equal the function value. Either because the function is not defined there, or it doesn't matter, it is defined, but somewhere else. Either it's not defined at all, it does not have that full point, or it has that full point, but it still doesn't matter. Okay, so the limits from either side exist. The limit from the left limit and the right limit exists. The limit from either side exists, but those are not equal to the function value at that point. Removable means basically I can create a function and make it continuous by defining this point, and I can define the point, not infinitely many points. This function will never be continuous. I cannot make it exist at that point. It's undefined. The same thing here. I cannot make it It's already, it exists at that point. But the left and right limit are not the same. Limits are not the same. So only this one is continuous, but from all these three, only this one can be turned into a continuous function by simply defining this value. One value I can make up, create a new function, just creating one more point. But I cannot do this here, and I cannot do it here. Any questions? Any questions? Okay, so let's look at a graph here before we look at a few examples. Okay, so is this function continuous between -4 and -2?
Yes.
Because it's continuous at each point, okay, on that interval. Is it continuous at -2? No. Is it continuous between -2 and 2? Yes, because it's continuous at every point on that interval. It's not continuous at 2, it's a jump discontinuity. It's not continuous at 4, it's an infinite discontinuity. It's not continuous at 6. Now, question. Is this function continuous from the right of 2? Yes. Because the limit from the right and the function value are the same. It is continuous from the right. Is it continuous from the left of 2? No, because the limit from the left-hand side as x approaches 2, the left-hand limit does not equal the function value at that point. So it is continuous from the right, but not continuous from the left. Is it here continuous from the right of -4? Yes, because the limit and the function value are the same. Is this continuous from left or right? No. So that's one thing I would like to write. Left and right continuity. And how it looks like. So the limit as x approaches a from the left of f of x equals f of x, or I should say f of a, that's better. Then function continuous from the left. Limit as x approaches a from the right of f of x equals f of a. This means what? Function continuous from the right. Now the most important item here is continuity at a point. Continuity at a point. And also I would like to write the definition of continuity on an interval. On an open interval. Okay, so the limit as x approaches a from the left, the limit as x approaches a from the right, and f of a. For a function to be continuous at a point, what has to happen? The limit from the equals right and equals function value at that point. All these three must be identical. Then the function is continuous at a point. If the left limit, right limit, and the function value at that point exist, they're all the same number, then the function is continuous at that point. Continuity on an interval. A function is continuous on an interval if it is continuous at each and every point on that interval. Excellent, yes. A function is continuous on an interval if it is continuous at every point on that interval, of course. $45, because I know I only have about 10 minutes left, less. Okay, so a short problem. For what value of the constant c is this function continuous everywhere, negative infinity to infinity, everywhere on all real line? Find the constant c, we call it parameter. Find the constant c such that this function is continuous at every point on the real line. Ready? Now let's take a look. Problem 45, page 129. Okay. So we're given a function f of x, cx squared plus 2x for x less than 2, x cubed minus cx for x greater than or equal to 2. Before we address this problem, I'd like to write a theorem. Polynomial functions are everywhere. What is the word I'm missing here?
Continuous.
Of course. They're nice. They're always continuous, everywhere, forever. Okay, perfect. Good. So my first step would be to write cx squared plus 2x and x cubed minus cx are always continuous as functions. I'm missing a word. Of course, of course, of course. As polynomial functions. The only concern I have is where. What is my only concern?
2.
Exactly. That's the only concern. Continuity at x equals 2. What has to happen? The limit as x approaches 2 from the left, the limit as x approaches 2 from the right, and the function value at 2. What is the relationship so that I say the function is continuous not only everywhere because they are polynomials, but also at 2 because it's a piecewise defined function.
They all have to be equal.
Exactly. So please give me what is the limit from this? What? Which branch?
Cx squared. plus
Excellent, excellent. Cx squared plus 2x must equal, and what do I write here?
X cubed.
Excellent. And what do I write here? Which one? Top or bottom branch?
Bottom.
Excellent. So this will be 2 to the third minus c times 2. Very good. So can anyone give us this limit? You don't care about my markers. I got it. It does it.
Negative 8c minus,
Say it again.
negative 8c minus 4.
But this is
Oh, no,
2.
sorry, plus 4.
Exactly. So this is, you're saying 4c plus 4 must equal.
I thought that was a cube.
It's here. Equals.
8 minus.
And this is still 8 minus 2c. There is no need to write it again, but let's write it again. So what do you think I'm going to do with this?
So, see,
It's a linear equation. Solve for c, and I'm done. Excellent. That's it. So 4c plus 4 equals 8 minus 2c. I will move 2c and I will move 4. When I move 2c, I get 6c. When I move 4, I get 4. So then c equals 2/3. I have to rewrite the function with 2/3 in it. So f of x equals 2/3 x squared plus 2x, x less than 2, and x cubed minus 2/3 x, x less greater than or equal to 2. What can you say about this function for sure forever?
that continuous
Continuous on
2. I don't know.
we already knew there was continuous everywhere except 2. We made it continuous at 2. We found c and we put it back in. So what do I know now about the function?
It's continuous everywhere.
That's it. Absolute guaranteed. Absolute guaranteed we made it happen.